ANOVA is another analysis technique that belongs to bivariate analysis technique, because we have only two variables, one independent variable and one dependent variable. And ANOVA actually stands for analysis of variance, right? ANOVA is for hypothesis or situation that we have independent variable with more than two groups. You remember for t-test, we compare only between two groups, two different situations. We compare satisfaction of male and female. But if our independent variable is more than two groups, or we want to compare a variable, a phenomena, between more than two groups, for example, ethnicity. We have a variable race, ethnicity. So we have three groups, we have four groups. Or we have nationality. We want to compare between different countries. We have 5 countries, data from 5 countries. Right? Satisfaction, loyalty between customers of 5 countries. So we have more than 2 groups and we want to compare between more than 2 situations. We have to use this one-way ANOVA. One-way ANOVA. So for one-way ANOVA, null and alternative hypothesis is something similar to this one. Okay. For example, if we have 3 groups, so we have 3 different situations. So we want to compare mean value of group 1, group 2, and group 3 for satisfaction. We want to compare satisfaction of group 1, 2, and 3, right? So null hypothesis is no difference between group 1 and 2, group 2 and 3, group 1 and 3. So all 3 groups are equal. The satisfaction of all 3 groups are equal. But this is null hypothesis. Alternative hypothesis is at least difference between 2 groups. So alternative hypothesis is at least there is significant difference between 2 groups, at least, but can be between all groups. So this is null and alternative hypothesis when we have more than 2 groups and want to compare. If we have more than 3 groups, here is for 3 groups. If we have more than 3 groups, so this will be equal mu4 equal mu5 if we have 5 groups. And this will be alternative hypothesis. Right? So if we have more than 2 groups in independent variable and want to compare dependent variable like satisfaction for more than 2 groups, we have to use one-way ANOVA. One-way ANOVA. Okay, to check this, for hypothesis testing in ANOVA, we have to use F statistic, and this is the formula for F statistic. We calculate variance between group and within group. So the variation between groups should be higher than the variation or variance within groups. So based on this, we can actually test significance of we can assess our hypothesis based on the value of F. Okay. Here is some formula for calculating variance within and between groups.
Can you explain what difference between and within groups?
Between groups means when you have 3 groups. So you calculate satisfaction for 3 different groups. So you calculate variance for all respondents from all these 3 groups, right? So this is between group. But when we say variance within group, means we go to group 1, race Chinese, and only calculate variance of Chinese respondent for this variable, and Indian and Malay, right? So within means respondent from one specific group, but between means variance for all respondents from different groups. So here, this is the formula to calculate F, and based on this F, actually we can see the significance of our hypothesis, null hypothesis and alternative hypothesis. If this F value is very low, means variation between group is lower than variation within group. So should not be significant difference between group. Or if this one is very close to 1, right? If this is very close to 1, so it means variance between group and within group should be similar, should be same. But if F is very high, means variance between group is higher than variance within group. So based on this, we can see result of hypothesis testing for null and alternative hypothesis, right? Okay. So this is the concept of ANOVA. Okay, let me go to software and perform ANOVA in software, Oneway ANOVA. Here you have race and age more than 2 groups. So I want to compare between different age group. I want to compare community attachment between, if I'm not mistaken, if I go to questionnaire, we have 5 groups. Yeah, we have 5 age groups. Yes, we have 5 age groups. So we want to compare community attachment between these different age groups, right? Okay. So for this one, because age variable include more than 2 groups, we have to apply Oneway ANOVA. So to perform Oneway ANOVA, similar to same place with the t-test. So we need to go to analyze and compare mean. The last one is Oneway ANOVA. If you click on Oneway ANOVA, what's your dependent variable? Dependent variable is community attachment. So we transfer community attachment to dependent variable box. And age is our factor or independent variable. We want to compare between different groups. So we click on age and transfer to this box. Okay. Later I will be back to this one. But if your data is non-normal, you have to click on bootstrapping, and here choose number of samples or number of resamples. Number of resamples here. Okay. And click on OK. So now we have result of one-way ANOVA. You can see output, right?
No, Prof. No, we can't see the output.
You cannot.
Cannot. Yeah, cannot.
No, it's still in the data view.
Okay, what about now?
Yes, can see it now.
Yeah, can.
Okay. Okay, so here you can see the result of one-way ANOVA for community attachment. Here you can see some of the squares of variance between groups and within groups, right? But it's not variance, actually is sum of a square, and we have to divide to degree of freedom to get variance between group and within group. But this F square, we have to interpret this F square, this F value. This F value. So the value of F is 2.39 and the P value is 0.05, right? 0.05 is significant. We can consider significant. Actually, P value should be lower than 0.05, but it's very close to threshold. So we can conclude the significant difference. So this result and this table show there is at least a difference, significant difference between at least two groups. But based on this analysis, we don't know which group, what this significant differences between which groups, right? So overall, based on this, we reject null hypothesis and we accept alternative hypothesis. So here you can reject null hypothesis, but still you don't know the differences between what groups. To understand this difference belong to what group, we need to do a post-hoc test. For this post-hoc test, actually, we have different methods and different algorithm to do this post-hoc comparison. When we go to software, you can see there are many different tests. But among these different tests, these two tests, 2key and the Shiffy test, 2key and Shiffy tests are more conservative. So we choose these two tests. Even one test, one post-hoc test and one test for comparison is enough. So you can choose only 2key, right? So when we go to software again to run one-way ANOVA, here we have the post-hoc option. We need to click on post-hoc option. Here you can see different tests. We can click on 2key and Shiffy test and continue. Don't change anything here. Only choose bootstrapping if your result is not, if your data is not normal, and click on OK. Okay. So when you click on OK, you can see again this table and one more table here. one more table here. In this table, actually, you can see the difference between different groups. You can see the difference between different groups. This is group 1. This is based on 2 key. This is group 1 and the other groups. So here you can see the difference between group 1 and group 2, right? And this is significance, and this is confidence interval, lower level and upper level. So the p-value for this difference, group 1 and 2 is 1, means there is no significant difference between group 1 and 2, right? Group 1 and 3, there is no significant difference. And also here you can see CI, confidence interval, 0 fall between lower level and upper level. So it's not significant based on both p-value and confidence interval. 1 and 3, 1 and 4, and 1 and 5. You cannot see any significant difference between group 1 and other groups, right? What about group 2? Okay, group 2. For group 2, also you cannot see significant difference between group 2 and the other groups. Group 3, there is no. Group 4, group 4, there is no significant difference based on this, and group 5. Here you can see, because when we look at F result, was very close to non-significant. Actually was 0.05. But we decided to accept because it's very close to 0.05. But when we come to detailed result and post-hoc result, actually we can realize that there is no significant difference between any of groups for community attachment. If we look at to another test, also based on this test, we cannot see any significant difference between one pair of groups, any of groups, right? So based on this post hoc, actually we can go back to original result of ANOVA and again interpret this one, because this in this test was very close to very close to threshold. Actually was threshold and not lower than 0.05, right? So based on this post hoc, we can report the result and say there is no significant difference between groups, and result of ANOVA show community attachment between different group of respondents are similar or almost same, and there is no significant difference. Okay, but let's try another variable and do the same one-way ANOVA, but change community attachment to, for example, positive perception, and post hoc these two tests. Okay, there is no significant. So here you can see F is very low and there is no significant difference between groups. Let's see, we can find the significant one. No. Let's try with the race and see. So we change age to race for economic gain. Okay. Here we have result. We have significant result for economic gain. So it's lower than 0.05. So should be some difference between groups. When we come to this table, okay, between group 1 and 2, there is no significant difference. But between group 1 and 3, okay, 1 and 3, here you can see significant difference. And also based on CI, 0 is not between these two values. Two values are negative. So this significant part of this difference of ANOVA refer to difference between group 1 and 3. And let's check other group, no significant two, between two, we don't have significant difference. Group 3, again group 3 and 1, and group 4. Only there is significance between group 1 and group 3. Not between other groups, right? So based on this Posthoc test, you can understand and interpret the difference between for economic gain and this significant result of ANOVA. The difference belongs to what groups? So based on this, you can interpret your result. For example, if group 1 is Chinese and group 3 is Indian, for example, right? And when here there is significant difference between group 1 and 3, and here we can see mean difference, right? Mean difference is negative. So here I minus J is negative. I is group 1, Chinese. J is group 3, Indian. So I minus J is negative, means economic gain of Indian is higher than Chinese significantly. But if this amount is positive, if this value is positive, it means group 1, the mean value of group 1 for economic gain is higher than group 2. So for interpretation of this Posthoc result and ANOVA, we have to also look at this mean difference for interpretation and see this value, this variable is higher for which one, right? Higher for which one? Okay. So this is for one-way ANOVA and Posthoc test. Here is the formula to calculate effect size. If you want to calculate effect size for ANOVA, one-way ANOVA, you have to calculate based on this formula. You have actually the sum square between groups, sum square within groups. You can get this value from software. So this is sum square between groups and sum square within groups. So you can use this value to calculate this effect size. And the threshold for effect size of one-way ANOVA is 0.01, 0.06, and 0.14. Means lower than 0.01 is not acceptable. 0.01 to 0.06 is small. 0.06 to 0.14 is moderate. And higher than 0.14 is high. Effect size is high for result of ANOVA.